Hi, in this video we'll discuss the lens formula and how to use it to find location of an image, its magnification, and also the lens system with combination of lenses. To start with, in our last video we talked about the lens maker formula which the lens makers use to find the radius of curvature of the surfaces they need to make for a particular focal length. It was very simple. So here we have a lens and this radius is R1, this was R2, and let's say it is in a medium with refractive index N1 and the refractive index of the lens is given to be N2, and the lens maker formula says that we can have a focal length f, right, given by 1 by f is equal to N2 by N1 minus 1 into 1 by R1 minus 1 by R2. You can watch the video on the lens maker formula on where we derive this formula, and also we know that 1 by f is also equal to 1 by v minus 1 by u, whereas the u is the distance of an object from the lens and v is the distance of an distance of an image from the lens, right? So with this 1 by f is equal to 1 by v minus 1 by u is also equal to, with the lens maker formula, n2 by n1 minus 1 into 1 by r1 minus 1 by r2. We also said that it's always difficult to deal in equations which are like 1 by x and things like that, right? So like 1 by x, 1 by f and things like that. So to make it easy, we defined a power of a lens which is defined as 1 by f and which is called power of a lens, which is a unit diopters, right, where f is in meters. So we can use that all, and then we also said that a magnification of a lens is nothing but magnification the size of image divided by the size of object, which is h2 by h1. Okay, and this is also equal to v by u with the right sign convention, right? So we have this two formulas in front of us which we'll use to solve all the problems of image formulation for the lenses. So the formula for image formulation, any lens, very simple, is 1 by v minus 1 by u is going to be 1 by f. If we know any of the two, we can find the third one, and similarly the magnification is given by h2 by h1, and this is also equal to v by u, right? So if we know the magnification, we can always find v or u and their relationship, and by using these two formulas we can always find the exact nature of the image and things like that, right? So let's revise the sign convention. Sign convention here is very similar to what we discussed. We are going to use the Cartesian one, right? So here is our lens. Okay, this is our lens. It could be converging or diverging, anything, and this is the O, and then the ray of light is always going to come from the left, so this side is going to be positive and this side is going to be negative. So any object or image falling on this side is negative, and any object or image falling on this side is going to be positive. For the converging lens or a convex lens in air, f is positive, and for a diverging lens or a concave lens in air, f is negative. Okay, so with this let's start and try to solve few problems to clarify this formula and the sign convention we want to use. So here is our first problem, which says that a thin converging lens of focal length 20 centimeter, right? So the lens type is converging, focal length for the converging lens is positive, so it is 20 centimeters. Is placed at a is placed 30 centimeter from the object in the air, right? So let's draw the diagram. So here we have the lens, and just I will put the object on the left hand side, so it is placed at a 30 centimeter. Now this is our sign convention. Ray of light is going like this. This is positive, this is negative, so U is negative 30 centimeter because it's falling on this side, right? So this side is positive, this side is negative. The height of the object is 3 centimeter, right? So we also have H1 is given 3 centimeters. We have to find the position, size and character of the image. So the position we can always find 1 by V minus 1 by U is equal to 1 by F, right? We know U, we know F, and we can just simply plug in to find the position. The size, we have to use the magnification formula, right? The magnification is given by V by U, right? So once we know the V and we know the U, we can find the magnification, and the character is the image inverted or erect, right? So the image is sort of so magnification comes positive in the sign, which means the image is erect. If the magnification comes negative, the image is inverted. Okay, so with this background, let's try and solve this problem by just simply plugging in the numbers. So here using this formula, V we do not know, so we'll say 1 by V minus U is negative, this is going to now positive 1 by 30, right? Minus minus plus, and F is positive, so 1 by 20, and when you solve for V, you will get 60 centimeters, right? So image is going to form on this side at 60 centimeters. This is a positive side, right? Now let's find the magnification. So M is equal to V by U, and V is positive 60 divided by U is minus 30. So the result is minus 2, right? So as I said, when you get a magnification negative, it means that the image is on the right hand side, right? Because V is positive, which means it is a real image. Okay, so real image is going to form the positive side on the lens, and then the magnification is minus 2, which means it is an inverted image. And now we can find the size by using simply H2 by H1. So the height of the image, H2 is going to be magnification into H1, right? Magnification is minus 2, and the height of the image is given in the problem to be 3 centimeters, so 3, so minus 6 centimeters. So it is an image which is bigger in size but inverted and in the negative direction. So now let's move to our second problem. A planar convex lens is made of a glass of refractive index 1.5, has a focal length 20 centimeters. Okay, so it's a converging lens, right? So F is going to be positive 20 centimeters. And now we need to find the radius of curvature of the convex surface. Okay, so refractive index is given to be 1.5. So now we are going to use the lens maker formula because we need to find the radius of curvature. Okay, so it's very simple. We will say 1 by F is going to be equal to N2 by N1 minus 1, 1 by R1 minus 1 by R2, and this will enable us to find the radius of curvature. So let's try and plug in the numbers. This is the N2, which is the index of reflection for the lens, which is 1.5. It is in the air, right? It's not given, which means it is air. So the lens is in the air, so N1 is 1. Assuming that it is a planar convex lens and the object is on this side, right? So we can say the R1 is infinity, right? Because the plane surface, and the R2 is, we don't know, right? That's what we need to find out. So with this information, let's proceed and put in the numbers here to find the value of R. Now F is positive, so 1 by 20, right, is equal to N2 is 1.5 by 1 minus 1, right, into 1 by R1 is infinity minus r2 we don't know, right? This means this will become 0, and when you solve for the r2, basically we get minus 20 centimeters. Okay, so when we have this negative r, right, so it's a planar convex lens, and as we assume that it is on this side, right, so hence look in the sign convention, r2 is coming negative, right, so it means on this side, right, so hence our assumptions are true. R2 is minus 20 centimeters or 20 centimeters in this case. Moving to the next problem. If a lens forms a virtual image, an erect image of an object placed at 4 centimeter from it, given the image is 1/5 in the size of the object, what is the nature and the focal length of the lens? Now again, it is like the mirror problem we did, right? So we do not know about what kind of lens it is, right? So it could be converging lens or a diverging lens. We do not know about that, right? We need to find that. It forms a virtual and erect image of an object placed at 4 centimeter from it, right? So it is placed at 4 centimeter from it. So we'll say u is minus 4 centimeter. So again, the ray of light is coming like this. This is positive direction. This is negative, right? So u is falling on the negative side. Okay. And the image is 1/5 of the size, right? So it is saying the h2 by h1 is 1/5. Okay. The magnification is given 1/5 of the size. That's all we know. And this is also going to be equal to b by u, like in the case of lens. As you said, we have these formulas, and if we can find two of them, right, we can easily find the third one. So in here, we said that if we know 1 by v minus 1 by u in 1 by f, if we can find two of them, the third we can find. And in this case we know u, we don't know v, but we don't know f, right? So we have to somehow find a relationship between v and u, which we can use the magnification formula to find that relationship. And once we know the v, we can plug in that number to find the f, and that's what we'll do. Okay, so very simple. Coming back here, we know the magnification, and now v is equal to u by 5. Okay, and the v and the u is going to be minus 4 divided by 5, and that is going to be the v, right? So now let's use the lens formula. 1 by v minus 1 by u is equal to 1 by f. Everything is known. We want to find the v, and the u is minus 4, so 1 by minus 4, right? And this is 1 by f, and the v is also known, so it is like 1 by minus 4 by 5 minus 4, and it's equal to f. And when you solve this, as expected, f is going to be minus 1 centimeters. Okay, which means that the lens is of concave type, right? So in our sign convention, we said that if the f is positive, the lens is converging or a convex in the air, and if f is negative, it is going to be a concave lens or a diverging lens. Okay, so f is coming to negative, so it's a concave lens with focal length 1 centimeter. Okay, so that is our answer, and that's what we wanted to find. So let's move to the next problem. Now a small object is at 30 meters from a converging lens of focal length 30 centimeters. A second thin and diverging lens of focal length 5 centimeter is placed at a distance of 25 centimeter from the first lens. So of course, now just by reading the statement of the problem, we know that now there are two lenses, right? So let's try and visualize that. So it is saying the small object is 30 meters from the converging lens. So here we have a converging lens first. Its focal length f for the converging lens is positive, right? And saying the object will be always taken on the left hand side, so 30 meters. Mind it, right? So if you read like 30 centimeters, you will make an error, right? So it's 30 meters. Okay, so the u is very large and it is 30 meters, and because it is on the left hand side, right, so negative territory, it is going to be minus 30, right, it's going to be minus 3000 centimeters. Okay, now a second lens which is thin and diverging of focal length 5 centimeter is placed at a distance of 25 centimeter from the first lens. So we have a second lens here, okay, which is at 25 centimeters. Now it is a diverging lens, so focal length of this f2 is minus 5 centimeters. Find the position, character and magnification of the image formed by this system, right? So the way to do is that first we are going to pass the ray of light from this first lens, and whatever image is formed will be used for the second lens as an object. Okay, so we are going to do step by step. So first thing first, we are going to write the formula and find the image formed by the first lens. Okay, formula is going to be same for both the cases, right? This is our formula. Whether it is converging or diverging, we don't care. For the first lens, okay, it is a converging lens. F is plus 30 centimeters given here, and the U is minus 3000 centimeters. Okay, you can put that over there. V minus 3000 is equal to 1 by 30. So go on that side, add up, and finally basically you will get V is equal to 30.3 centimeters. Okay, now V is equal to 30.3 centimeter in the positive side, which means that from here, right, it is about 30.3 centimeters on this side. Now this lens is placed at just 25 centimeters, so the object for this image, for this lens 2, right, is going to be on this side. Now let's look at the lens 2. So the ray of light is coming like this. So this is a positive side, this is a negative side, right? For the lens 2, let's rewrite the equation. Okay, so we now have only view of the lens 2 and the formula is same. And now first thing first, we'll write the focal length. For the diverging lens, it is going to be minus 5 centimeter. That's fine. And the U is now over here on the positive side, right? And how much? So it is on totally 30.3 centimeter on this side, minus 25, right? So this distance is equal to 30.3 minus 25. Okay, so this U this time is positive, which is 30.3 minus 25, and this is going to be plus 5.3 centimeters. Now we know F and U. We can simply plug in the number to find the location of the image. In this formula, it's going to be 1 by V, and U is positive, and F is negative. And when you do that, basically you will find the V is equal to minus 88.3 centimeters. Now we got a negative number and 88.3 centimeters from this position, right? Because that is our coordinate for the second lens. So roughly in this direction, about 88.3 centimeter, the final image will be formed. And because on the left hand side, the image is going to be a virtual image, right? Now let's find the magnification. When it comes to the magnification, the formulas are very simple, right? So you have one lens which produces a magnification of M1, then you have second lens which produces a magnification of M2. Let's say you have a mirror which produces M3. So any kind of object, basically the final magnification is a multiplication of this with the right signs. Okay, very simple. So here we have two lenses. So the final magnification M in this case is going to be the multiplication of these two magnification. So magnification final M1 into M2. Okay, so for the first lens is going to be V by U. Okay, it's going to be V1 by U1 multiplied by the second lens, let's say V2 by U2. Okay, now V1 for the first thing, right? Where is the V1? We already found that over here, which is positive 30.3. Okay, so let's write it down first. So before plugging in the numbers, V1 is positive 30.3 and E1 was minus 3000. You remember for the first case. Now V2 is now negative here, right? So minus 88.3 and U2 is positive here because the object is on this side and that was 5.3. Okay, 5.3 positive. Plug that in over here, you will get 30.3 divided by minus 3000 multiplied by V2 minus 88.3 divided by plus 5.3. Okay, minus minus will cut, and finally the number you will get is, it is less than 1, right, but positive, which means that the image is inverted, right? This is a positive sign, this is a negative sign, right? So image is inverted but of smaller size. So with this we conclude this video. As I said, no, it is very simple. If you know the lens formula, 1 by v minus 1 by 1 is equal to 1 by f, and then we can use the same with n2 by n1 minus 1 is equal to 1 by r1 minus 1 by r2. Then the magnification is the height h2 by h1 is equal to b by u, and with this we can plug and play the numbers between this formula to find everything about the image or the object or the lens. So with this in the next video we'll have more examples of combination of lenses and mirrors, and that is what will matter because in the exams that combination is going to come. So this is a fundamental on which we are going to build. Till then, if you want to watch more videos, you can go to deep dive physics.com, where you can register and watch videos without any advertisement and in the sequence so that you can build your concept. And we also provide one-to-one and small batches tuitions for IIT, JEE and NEET. So if you are interested, please get in touch and we'll take it from there. Thank you very much for watching.